In this lesson, I'm going to be explaining to you the concept of graphical representation of data. So graphical representation refers to the use of charts, graphs, to visually display, analyze, interpret numerical data. Examples of graphs or charts are histogram, bar chart, and pie chart. There are so many other graphs, such as pictogram, line graph, there are so many other graphs. We are going to focus on histogram, bar chart, and pie chart. The first step, like I said before, in the statistical process is to gather data. Once you have gathered your data, you analyze your data, and finally you present your findings on a histogram, bar chart, or pie chart, or any other charts or graphs you choose to use. So histogram is a graphical display of data using bars of different height joined together. It is similar to bar chart, but a histogram groups members in ranges. By this, grouping numbers in ranges means that I need my class boundaries to draw my histogram. And the bars are usually joined together. This is an example of histogram. As you can see, the bars are joined together. They are joined together, unlike bar charts that looks something like this. The bars are not usually joined together. The bars are not usually joined together. So that's one major difference between bar charts and the histogram. The bars are not usually joined together. You can see space between these two bars, and the space must be equal, but we'll still look at bar chart later. For now, we are looking at how to construct histogram. So example, the table below represents the length of some similar objects. Draw a histogram to represent the information. So this is the frequency table you are given, and you have to draw a histogram based on this information you are given. So lengths, these are the lengths of various objects, and these are the frequencies. The major thing you need for histogram is to get your class boundaries. Okay, so let's get our class boundary. Let's get our class boundary. Now, before I continue, class boundary is gotten from the previous lesson. It's gotten by subtracting 3 from 4, and that will give you 1. It can be 8 minus 7, 12 minus 11, anyone you choose to use it. 16 minus 15, you will get the same answer, 1. So the last class, limit of the first class interval and the first limit of the next class interval, you are going to subtract the 2. So that will give you 1. 1 divided by 2 is 0.5. So 0.5 will be subtracted from this class interval, and it will be added to the next. To be separated from the first class limit, and to be added to the next class limit. So all these limits are the lower class limits. You need to subtract 0.5 from all these limits, and you add 0.5 to all these upper class limits. So let's do that now. Okay, so 0.5 minus 0 minus 0.5 is minus 0.5 minus 0.5, and 3 plus 0.5 is 3.5. So let's continue. 4 minus 0.5 is 4.5. 4 minus 0.5 is 3.5. 7 plus 0.5 is 7.5. 8 minus 0.5 is 7.5. 11 plus 0.5 is 11.5. 12 minus 0.5 is 12.5. 12 minus 0.5, sorry, is 11.5. 15 plus 0.5 is 15.5. 16 minus 0.5 is 15.5, and 19 plus 0.5 is 19.5. So we have successfully gotten our class intervals, which we are going to use to construct our histogram.